Hello everyone. So this is problem 5 of the ICPC Online Preliminaries to the water reservoir. So this is a relatively simple problem. I mean, at least in terms of wording, they don't have really huge paragraphs, and you can also get a good idea what they're asking for by just looking at the diagram. So we have a list of numbers and we have to find the maximum amount of water that we can store at any position, at one single position. So we can store 3 boxes of water here and then around 8 boxes of water here. So the maximum will be 8 and that is our answer. So we have two lines of input. One is the length of our array and second is our array, right? So the way we go about this solution is that actually there are two solutions. One is the brute force solution, which uses O of n memory, and there's the optimized version by two pointers, which uses O of 1 memory, but both of them use O of n time complexity. So the way that we go about this solution is that what we can do is for each position, we can find the left max and the right max value for each position. So let's say for 4, we can find the left max value and the right max value. So for 4, the left max value will be 6 and the right max value will be 4. Oh, sorry, the right max value will be 5, right? So what we can do is we can take the minimum of 6 and 5, which will be 5, and then we can subtract that by 4. So that will give us the amount of water that we can store at this position. So that is the main formula that we'll be using throughout the solution. So for each position, we'll use this logic that, let's say for 3, we'll find the left max value and the right max value. So for 3, we can see that the left max value is again 6 and the right max value is also 5. So the minimum of 6 and 5 would be 5, and then 5 minus 3 is 2. And that is the amount of water that we can store at this position. So what we can do is we can create two arrays, left max and right max, and we can use two for loops, not nested, two separate for loops. One can run from this side to calculate left max, and one can run from this side to calculate right max. So as we can see that 4 has a left max value of 0, 6 has a left max value of 4, and then after that all of these positions have a left max value of 6, because 6 was our highest value. Same is the case for right max. 1 has a right max value of 0, 2 has a right max value of 1, 3 will have a value of 2, and then so on. We can then create a new array, which will tell us the minimum of the left max and the right max. So for 0 and 6, the minimum value is 0. For 5 and 4, the minimum value is 4, and so on, right? So then what we can do is we can easily calculate the amount of water that is being stored at each position. So let's say at this position 5, 5 is our minimum value. 5 minus 3 is 2. We can store 2, right? And similarly, 5 minus 2 is 3. 5 minus 4 is 1. And then 5 minus 3 is 2. But here we have 4 minus 5. 4 minus 5 is basically minus 1. We can't store a negative amount of water, so that will essentially be 0. At this point of time, most of our work is done. We just have to identify consecutive pools of water. So we can see that, okay, there's a 0 here, there's a 0 here. So this is one consecutive pool of water. We can sum these values in a temporary variable, and once we find, okay, our pool has ended, we can compare it with our result variable, which will be outside the for loop that we're computing these. So this will be computed here, and similarly we'll also do this for this consecutive pools here, 1 and 2, right? Eventually we'll get the answer of 2, 3 is 5, 5 and 1 is 6, 6 and 2 is 8. So we'll get our final answer of 8. Okay, so now let's move to the more optimized version, the two pointers version. You can see that we use some extra memory here. The two pointers solution will not use that. The main logic, although will remain the same, is that for each position, we'll be calculating the amount of order that we can store here, 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 and so on. We'll have two pointers, a left pointer pointing to 4, a right pointer pointing to 1, and we'll also be maintaining two variables, a max left, which will tell us the maximum left value, and a max right, which will tell us the maximum right value. Another thing that we need to take care of here is that when moving pointers, we'll always move the minimum pointer. What I mean by the minimum pointer is that if we have 4 here and a 1 here, we'll always move this pointer, right? Um, why are we moving the minimum pointer is that, let's say for this 2, I am 100% sure that the right max value is 1, but I'm not sure of the left max value, right? The left max value is 4 at this point of time, but it can be greater than that, right? So I'm not sure of the left max value. But nevertheless, what the left max value is of no concern, because I need to be only concerned of the right max value because it is smaller than the left max value. So what I'll be doing is I'll be doing the right max value minus this value. So 1 minus 2 is essentially minus 1. We can't store negative amount of order, so we'll have a 0, and we'll move this pointer to here. So once we move this pointer here, and before we update our max right value, we'll subtract this value. 1 minus 2 is 0, so we'll have a 0 here. And then we'll update our uh, before we started our for loop, they were 4 and then they were 1, and now we have moved our right pointer, so our max right value has become 2 now. Okay, so now uh, our left pointer is here and our right pointer is here, right? Again, we'll see that 2 is smaller than 4. We'll have to move that pointer again, so our right pointer will shift here. Once we've shifted to here, what we'll do is subtract the max right value from here. So 2 minus 3 will again be 0. And once we have computed that, we'll shift our right pointer to here. And then once we've shifted to here, we'll update our max right value. You can see that 4 hasn't moved and our max left value hasn't moved as of yet. So again, this will be the case for 3. Same thing will happen and we'll eventually get to 4. At this point, two values of the left and the right pointer are equal. We have a choice here. We can either move the left pointer or the right pointer. Since we're moving the right pointer, let's just keep on moving that. So now we have to move this pointer to here, and our max value will be 4. So when we came here, our max value would have become 4. So 4 minus 2 will essentially be 2. So now you can see that 4 minus 2 is 2, which is essentially the amount of water that we're storing at this position, right? So once we move our pointer here, we will not be updating the max right value, because this max right value will only be updated when we find a value greater than the value that we already have here, right? So our value here is currently 4. So again, we'll have a look that, okay, we have 4 here, we have 2 here. We'll have to move this again. Our right pointer will come here, and then we'll again calculate 4 minus 3 is 1. So we'll have 1 here. Our right pointer will be shifted to here. We'll not update 4. And then our right pointer will come here. Right. And then our max right value is 4. 4 minus 4 is essentially 0, and a 0 will come here and will not be updating our max right variable. So our right pointer is now here. Again, these two values are equal. We have a choice of either to move this or this. Let's just move this. So if we move it here, what you can see is that our max right value is currently 4. 4 minus 5 is essentially minus 1. We can't store negative amount of order. We'll have a 0 here. But our max right value will now become 5. Okay? And our right pointer is here. Now, what we can see is that our left pointer is pointing 4, our right pointer is pointing to 5. The minimum value is 4, so now we'll have to move the left pointer. So if we move the left pointer to here, um, if we move the left pointer to here, our max left value was 4. 4 minus 6, 4 minus 6 is minus 2. We can now store negative amounts of order. A 0 will come here, but our max left value will become 6 now. Okay, so now we have a 6 here, and now we have a 5 here. We'll have to move this pointer again. So now we'll do this pointer will shift to here, and this will become our right pointer. But 5 minus 3 is positive 2, so we can store two amounts of water here, and our right pointer shifted here, but will not be updating the MR value because we only update it when we find a value which is greater than our current value, right? So now we'll have to move this pointer again to here because the right pointer is smaller, and then again 5 minus 4 will be 1, and then we'll have to move this again to here, and then 5 minus 2 will be 3, and then we'll have to move this again to move the right pointer here, and then 5 minus 3 will finally be 2. We'll be implementing this using a while loop while L is less than R. So eventually this loop will end once the right pointer moves to here. So this will be implemented easily using a while L is less than R condition. I'll show that to you once in a second. Okay, so in this way, we'll essentially be creating this array, this water array from using pointers, right? But we can also cut this, and we can because this is also using an open memory. What we can do is whenever we find a position at which we are storing zero amounts of water, we can just simply compare our current pool with the result variable. So what I'm saying is that whenever we find zero, let's say we find a zero here, okay, at this point of time, our pool will be of zero, but we're still gonna be comparing that with our result at this point too. But once we're at this zero, our pool will all be of 3. So we'll be comparing our result variable with 3. So our result variable will get updated because it wants the maximum value. Same here, we'll be comparing our result variable with 3. So once it has already been updated, nothing will happen here. But once we'll come to this 0, our result variable, which is currently storing 3, will be compared to this temporary variable, which would have stored 8. So now our result variable will be updated to 8. So in this case, we'll also eliminate the use of an extra array of water, right? So let me now show you the implementation, right? So this is the inputs that we're taking. L is the length of the array, H is the array itself, and this is some cool Python trick to create an array. So you can basically create an array using map and int. So this is most basically used in all of the questions, and it's better to use it instead of using a while loop and inserting values one by one. Anyway, so let's just move to the main implementation. Uh, L and R are my left and right pointers. As you can see here, these were my pointers, and they were initially at the 0 and at the n minus 1 position. So this is my L minus 1 position or n minus 1 position. And then I have my left max and right max. They were initialized with 4 and 1, and here you can see that they're initialized with 4 and 1. And then this was what I was telling you, that this is my temporary variable current count, and then answer is my result variable, right? So I have implemented using while loop. So the condition is while L is less than R. So the basically the loop terminates when this right pointer shifts to here, right? So the loop will terminate here. So the first condition is if left max is less than right max, that is when the left pointer or basically the left pointer is smaller than the right pointer. So that is when I'm shifting my left pointer, and else I'm shifting my right pointer. So uh, this does that, and then there's another condition which checks the break-in value. So if there is ever a position, like say when I had um when I had 2 and then when I found 3, so 3 was greater than my maximum right value. So at that point, my HL was basically greater than LF max. So that indicates that there is a break-in value or a break-in pool. So I just calculate, I just compare the temporary variable with my result variable and get the maximum value. Then also have to initialize it back to 0 and then update my left value. Else, if this is not greater, I just update my temporary variable with the just like I was doing updating, like I was getting 2 here and then 1 here. I'm just inserting that into my current variable. And that is also the case with the right pointer. So that was the solution and that was the idea behind that. Hope you like it. Thank you.